Hey everybody, this video is going to talk about rational exponents. So exponents that are just kind of like fractions. So we're going to look at how we can go in between the exponential form and the radical form. So if I have a to the 1 over n power, that's really the same as taking the nth root of a. If I have a to the m over n power, that n, the denominator of that fraction, is going to become the index. And then underneath the radical here, we would have a to the m power. So we're going to be looking at some converting back and forth here. So let's convert from exponential form to radical form. So if I have 15n to the 1/2 power, that's the same as taking the square root of 15n. If I have 7 to the 2/3 power, that's the same as doing the cube root of 7 squared. And you know, we could go through and try to break these down. I'm not going to focus on that in this video since we already know how to do that. I'm going to focus just on, converting back and forth here. Okay, we can also go the other way. Okay, if I want to go from radical form to exponential form, I am going to essentially take whatever's underneath my radical, put it in parentheses, okay, consider the exponent that's there, and then I'm just dividing that exponent by the index. So this would be the same as 16 to the 1/3 power. Over here, I'm going to put all of the 8w in parentheses to the first power, and then divide that exponent by the index. So this would be the same as 8w to the 1/4 power. And again, we could then apply some exponent rules. We could convert it back to radical form. There's a lot of things we can do. Okay, this is just a nice strategy for if we need to go back and forth. Okay, so let's look at how we can, simplify expressions with rational exponents. So the first thing that we're going to do is we're going to make sure that all of the radicals are written in exponential form first. Then we're going to use our exponent rules, and then we're going to convert back to radical form and then simplify as much as possible. Okay, so here we're doing some multiplication. I have p to the 1/4 times p to the 3/2 power. We know that our exponent rules tell us that these, when they multiply together, should have their exponents added. Okay, but we have two fractions, right? 1/4 plus 3/2. Anytime we're dealing with fractions, we need a common denominator. So I'm going to rewrite 3/2 as 6/4, right? It's the same thing. If I reduce that, I get 3/2, but this allows us to actually add these two things together, okay? So p to the 1/4 times p to the 3/2 will become p to the 7/4 because I'm adding those exponents. Now what I can do is I can convert this to a radical, so that would become the 4th root of p to the 7th, and then I can break this radical down. Well, let's see, let's split this into the 4th root of p to the 4th times the 4th root of p cubed. Now I can take the 4th root of p to the 4th to get just p, and I have this 4th root of p cubed left over. All right, let's see another one here. So again, we're going to start by just using our exponent rules. Okay, I have a power raised to a power. Our exponent rule, the power rule, tells us that these exponents should multiply. Multiplying fractions is super easy. You multiply the numerators together, you multiply the denominators together. So this would give us a to the 5/6 power. Let's convert this to a radical. So it would become the 6th root of a to the 5th, which we can't break down because the exponent is already smaller than the index. All right, last one here. So notice this is a little different. This one starts in radical form. The problem is I have a 4th root times a square root. There's nothing I can do to simplify this. Okay, that's something we talked about back in one of the earlier videos. In order to be able to multiply radicals, they have to be the same root. So our strategy here is, let's get it into exponential form first and then see if we can deal with it that way. So the fourth root of r cubed will become r to the 3/4 power. And then the square root of r will become r to the 1/2. Okay, so we had a problem similar to this, right? We said if two things of the same base are multiplying, the exponents need to add. So I need common denominator between my exponents here. So I'm going to rewrite 1/2 as 2/4. Okay, now I have that common denominator, and I can add those exponents together to get r to the 5/4 power. So notice, this is allowing us to actually multiply. We couldn't multiply the roots together when they were radicals, okay, but after we converted it to exponential form, we can, and now we can actually convert back to radical form. Okay, we can write this as the fourth root of r to the 5th power, and then break it down, okay, split it into 2 fourth roots. We can do the fourth root of r to the 4th and r, which is going to give us our final expression here, r times the fourth root of r. So the focus of this video is really just to show you this strategy of how we can use this exponential form to get around this issue of not being able to multiply different kinds of roots together. If I need to multiply a cube root times a fourth root, convert them to exponential form, multiply them, and then convert it back to radical form. Okay, so hope that makes sense. Let me know if you have questions, and have a wonderful rest of your day.